Ya inició.
Ok. Somos el equipo 5. Vamos a hablar de diferentes temas de programación del grupo 003 y nuestros compañeros son Jesús Osvaldo Cárdenas Gallegos, Óscar Viniegra Aguayo, Joel Mariano Flores Montemayor, Víctor Enrique Maldonado Portillo, Juan José Delgado Huerta, Adrián Vázquez Guajardo.
Introduction. Computing has been evolving from a single machine handling a simple task into a network of machines spanning from a local area networks to such massive networks such as the World Wide Web that every day try to resolve computing problems that no single machine can handle alone, thus needing to work concurrently to solve a problem. We'll dive into this chapter and learn about programming language design that has allowed such development to be possible. Exception and exception handlers. During the execution of a program, events or conditions often occur that might be considered exceptional rather than continue with a normal program execution. A subprogram needs to be called to perform some special processing, including error conditions, unpredictable conditions, tracing, and monitoring. Although we could insert explicit text to test these exceptions, there are some checks or marks called exception handlers that trigger when an exception or signal appears and then proceed to do the testing. This whole process is called raising the suspicion. Particularly in Ada, there are a class of exceptions called checks or conditions that require code to execute at the time. Index check is constraint error exception that triggers when an array bound is invalid. A screenshot of CodePeer static analysis tool CodePeer 2.4 automatically checks the code being developed even after being modified thoroughly and finds potential problems that might arise after the code is compiled. It achieves it by using control flow, data flow, and other advanced static analysis techniques, saving the developer hundreds of hours of debugging.
Exception handlers. Since an exception handler is invoked without an explicit call, it ordinarily does not require a name or parameters. It normally only needs a set of declarations of local variables if it needs one, or a sequence of executable statements. Uh, each class of exceptions is given a name, and these names might be predefined by the language or be defined by the programmer. And these exception handlers are normally located at the end of a program or larger subprogram that needs to be checked with this. Here on the right, it's a
Coroutines are a type of subprogram that can be paused and resumed later. They are useful for writing scripts and game development. ADA supports coroutines through the use of tasks and task synchronization called Redens Boost. The easiest ways to implement coroutine in ADA is to use a type of task synchronization called Redens Boost. Here is an example of coroutine inner task with an entry. The task will run it until it reaches an accept statement and then waits for some other task to synchronize with it and so on. On the other side, we instantiate the coroutine and call the continue entry. Here's an example.
schedule subprograms. In ADA, schedule subprograms typically involve the use of tasks and time entry calls. tasks represent the concurrent units of execution, and time entry calls allow tasks to synchronize their actions based on specified time intervals. This mechanism is particularly useful for scheduling the execution of specific operations in concurrent and real-time era programs. What this means is that scheduled subprograms are pieces of code that can be scheduled to be run when, for example, an execution after auto subprograms, an execution when a Boolean expression is true, a execution on the basis of a stimulated timescale, or an execution based on priority. This means that when these requirements are made, the scheduled subprograms are going to be run by the compiler.
Parallel programming. The process of decomposing a problem into smaller tasks that can be executed at the same time using multiple compute resources. A current execution. The execution of a current program consists of multiple processes active at the same time as discussed in the last chapter. Each process is the execution of a sequential program. A process progresses by submitting a sequence of instructions to a processor for execution. Guarded command. The term guarded command, as defined by Dijkstra in 1975, is a synonymous with a conditionally executed statement. More precisely, a guarded command is the combination of a combination, a Boolean expression that is B, and the possibly compound statement that is S, whose by the execution is controlled by B. Ada. Ada is a modern programming language designed for long-lived application and embed systems in particular. Where reliability and efficiency are essential, it was originally developed in the early 1980s. Overview. Ada is a multifaceted. From one perspective, it is a classical stack-based general-purpose language, not tied to any specific development technology methodology. It has a simple syntax, structured control statements, flexible data composition facilities, strong type checking, traditional feature for code modularization or subprograms, and a mechanism for detecting and responding to a exceptional runtime condition, that is exception handling.
Now we are going to talk about tasks. The basic idea behind tasks is quite simple. Consider a subprogram A being executed in the normal fashion. If a call subprogram B, then ordinarily execution of A is suspended while B executes. However, if B is initiated as a task, then execution of A continues while B executes. The original execution sequence has now split into two parallel execution sequences. Either A or B or both may now initiate further. Task allowing any number of parallel execution sequences to coexist. Synchronization of tasks. In the realm of concurrent task execution where tasks progress independently and asynchronously, synchronization becomes crucial for effective coordination. Tasks may be at different stages simultaneously, necessitating mechanisms for signaling and communication. For example, in a scenario where one task manages an input device and another processes data batches, signaling ensures tasks operate in harmony. The synchronization process, current time resume calls, allow tasks to coordinate without interacting with each other. However, unlike current times that typically follow a single execution sequence, concurrent tasks involve multiple sequences operating concurrently. Interrupts, a common hardware mechanism, also contribute to task synchronization by momentarily pausing program execution to address specific events. In summary, synchronization, whether through signaling or interrupts, is essential for maintaining order and preventing conflicts in the dynamic landscape of concurrent tasks execution.
Our developments refer to improvements and advancements in physical components of a computer and other electronic devices. Some recent trends include solid state memory, SSD. SSDs have gradually replaced traditional hard drives in many applications due to their fast read and write speed and lower power consumption. Quantum processor research and development is underway on quantum processors, which take advantage of the principle of quantum mechanics to perform extremely fast calculation compared to classical processors. 5G connectivity deployment and expansion of 5G network has been a major breakthrough for wireless connectivity, providing significantly faster data transfer speed.
The processor design. Let's go now turn to the processor design where efficiency and power take center stage. Here we encounter two main approaches, complex instruction set computing and reduced instruction set computing. The RISC architecture stands out for its reduced set of instructions and it focused on an efficient register and based pipeline. In contrast, the CESC architecture is characterized by its complete set of instructions and frequent memory access, enabling the execution of complex instructions. This design not only addresses different challenges, but also shapes the landscape of modern computing, providing flexible and adaptive options to meet diverse needs. System design. Finally, system design addresses the creation of complete computer systems considering the interconnection of hardware and software. We will highlight three crucial aspects in this domain. Firstly, distributed system architectures. With the expansion in with expansion increasing the data and the demand of rapid processing, distributed systems allow for the efficient use of resources by distributing tasks among multiple nodes. And cloud computing, on the other hand, has revolutionized system design. It provides remote access to computational resource and service over the internet, enabling unprecedented scaling and flexibility. And of course, in a increasingly threatened digital world, system security has become a priority. System design now incorporates robust measures to protect the integrity and privacy of data, addressing the growing security threats.
Software architecture. Software architecture is the software is the structure, design, and organization of the computer system in the involved decision about the components, internet connection, patterns on the sure is the software meets its requirement efficient and sustainability. Key aspects including modality, scalability, and his own maintenance. Highlights the importance of networks and display servers competing and distributed. Um, Similar architecture is the model client the computer request server of the resource of the product service communication and the stability request and response is the allow states to the secretary on collaboration is the better one. This based on network persistent data and transmission system is the persistent data is the transition system for the efficient information magnet. Transition is the integrity of data during operation. Will persist ensure that the data is preserved of the long term typically during the database. Target is the facility to reliability and consistency of the information across application and systems. The transition is also the data integrated during operation is the precise answer long term and preservation is the to data to the system contribute to reliability ecosystem on information in the application and systems. Um, Next diapositive is new works and client servers competition. New works and the client servers competitive, and the format is the architecture distributed system and is the model compute the clients request the servers on the resource of a new work. From the computer servers is the appropriate of the communication is the base request and response facility, the consolidation of text, the collaboration between new work. The importance of new work is on the client-server composition is the architecture of distributed system. Um, Means the model client computers request servers and resource on the new work from the service computers establishing communication based on requests and responses. Thank you.